This is Algebra 1, Lesson 10-5, Quadratic Word Problems, Factored Form. Today's date is Friday, April 3rd, 4/3, 2020. I'm using a slightly new setup, using a Windows computer. Let's see how much it changes. Our objective today is to use properties of factored quadratics to answer questions within context. All right, so example 1. We have a skier going off a jump. The skier's height x seconds after takeoff is modeled by this function h of x. All right, so we're answering all of these questions about this one function. Here we go. What is the height of the skier at the time of takeoff? Well, if x represents the seconds after takeoff, then we haven't taken off yet, which means x is equal to 0. So that means I need to plug in 0. So I'm going to plug in 0 into both this x, and that's going to give us what? It's going to have, it's going to be negative, in parentheses, 0 plus 1 times, it's not x, is 0 minus 5. 0 minus 5. And that's going to be negative 1 times negative 5. 1 times negative 5 is just negative 5, and then negative times negative is positive, which means our answer here is positive 5. All right, next question. How many seconds after takeoff does the skier land? All right, well, that's when my height is 0. So when my height is 0, that's either taking off or landing, and which of them is the one that is landing, right? So I'm using the zero product property here. This is going to be setting h of x equal to 0. So that this h of x right here is gone, it's just 0. And let's go ahead and rewrite it down here. This is not going to be 0 is equal to negative x plus 1 times x minus 5. So erase that, x minus 5. And I'm going to multiply both sides by negative 1, which essentially gets rid of this negative sign. When I do that, I'm going to use the zero product property here, and I'm going to say that x, maybe I can do this in the top left, because otherwise I'm going to, or top right, I'm going to run out of room. So it's going to be x plus 1 is equal to 0, or x minus 5 is equal to 0. Solving both of those, I'm going to subtract 1, subtract 1, subtract 1, and I'm left with x is equal to negative 1, and let's add 5, and x is equal to 5. So it looks like I'm at a height of 0, negative 1 seconds before the jump, which makes sense, and then I go up the ramp, right? And then 5 seconds after the jump, I land. So the answer here is 5. All right, next question. At what time does a skier achieve the maximum height? And this one is going to come up more often than any other question. So if I had to star any one question, I would say this one pay special attention to. It's going to be asked more often than the others. If you ever see the words maximum or minimum, so I can say or minimum, this will always 100% imply the vertex. So this symbol right here, it looks like an arrow to the right. I read this as implies. This implies you're looking for the vertex. Vertex. And I can spell. So the vertex is halfway in between the two x-intercepts. If we come back up here, actually you don't even need to see that since we did some work. We know that the x-intercepts are at negative 1 and 5, which means I need to find halfway in between them, or I can just take their average. So I think undoing those is faster than erasing them. So what is the average of these two x-intercepts? Well, we can add them together. So I can say negative 1 plus 5, those are x-intercepts divided by 2. That's going to be the average of these two x-intercepts. So adding them together, that's 4 for the numerator, still 2 in the denominator. This simplifies to just 2. This is the x-coordinate, or the time of that maximum. So I'm done. It's asking for the time of the maximum. There it is. If it was asking for, let me make that box a little bit better. If it was asking for what is that maximum, which is the next question, it's slightly different. Not only do I have to find that time, but I also have to plug it back in to the formula. So let's come down and do that one. What is the maximum height of the skier? Well, I'm plugging in this 2 into our equation up here. So what is our equation going to look like then? It's going to be our y value is equal to negative, and then I'm plugging in here this negative 2 or negative, and then in parentheses 2. And I still have the plus 1 times the quantity of, okay, I'm plugging in 2 again, so 2 gets plugged in, minus 5. And then I'm going to solve. Again, I'm just plugging in the time that I have the maximum to figure out what the maximum is. All right, so after plugging those in, I get y is equal to negative 3 times negative 3. And hey, this looks familiar to our last lesson where these should be opposites of one another. All right, well, I'm running out of room, so I'm going to come back up here. And I'm say negative 3 times, or 3 times negative 3 is negative 9, so I'll have this negative times negative 9. I guess this is all really y is equal to that, right? Y is equal to negative, in parentheses, negative 9. And therefore, if I come back to my original color, y is equal to just positive 9. The skier goes up to a height of 9. I don't know what my units are. 9 feet, 9 inches, 9 meters, who knows? And then finally, the last question, at what times is the skier at a height of 0? And we've asked this already in a different form. So we've asked it up here for the x-intercepts. Where do we do the x-intercepts? We did the x-intercepts right here. How many seconds after takeoff does a skier land? It's essentially the same type of question, except this is only asking for one of them, but now we're asking for 2 of them. We're asking for both of them. So whenever it's asking for, like, when do you have 0 profit or 0 of anything, you're setting this h of x up here to 0. All right, so let's come back down here and set that h of x to 0. So I have 0 is now equal to this negative x plus 1 times the quantity of x minus 5. And then use the zero product property again. You can kind of just use some shortcuts, so you can say x is equal to negative 1 and x is equal to 5. We've done all the math before. You just kind of take the opposites of these two. All right, and I guess I should box those. Oop, I should make a nicer box. All right, and that concludes our notes today. I'll see you guys tomorrow. Actually, no, I won't see you guys tomorrow because it's going to be our week off. So I'll see you guys way back on Monday.